You were asked to estimate the area under the graph of f of x equals x cubed plus 1 from x equals 1 to x equals 3. And you were going to use 4 rectangles, and you were going to do both a left endpoint estimate and a right endpoint estimate. So the first thing you should do is draw a graph. So here's a graph of the function, just so you can get a sense of the area that we're talking about. In this case, the area we're talking about is between 1 and 3 underneath the curve. So we're talking about all of this area here. That's the area we're going to try and estimate. Okay, let's start by looking at the left endpoints. So here's a graph of the function with the 4 rectangles, and we're looking at the left endpoints, so the height of each rectangle is determined by where the rectangle meets the function on the left. Okay, so let's calculate. So for left endpoints, we call this L sub 4. The L means left, and 4 means we have 4 rectangles. Now, each rectangle has a width of a half, and the height is going to be different for each of the 4 rectangles. So for the first rectangle, the height is equal to the value of the function at 1. If you see here, that smallest rectangle, the height is determined by where the function meets with the top of the rectangle. So that's the value of the function at 1 times the base of the rectangle, that's a half. Plus the next rectangle, rectangle number 2, is the height of the rectangle is the value of the function at 1.5, and then the base is again a half. And then the third rectangle, the height is the value of the function at 2, and again we have a base of a half. And finally the last rectangle, the height of the function, or the height of the rectangle is the value of the function at 2.5, and again the base is a half. Now if you notice, the base is always a half, so what I could do is just factor out that 1/2. So let's do that. So I have a 1/2, open my bracket, and then I have the value of the function at 1 plus the value of the function at 1.5 plus the value of the function at 2 plus the value of the function at 2.5. Okay, and then close the bracket. And now I'm ready to plug in for the actual function. So the value of the function at 1, well, that's going to be 1 cubed plus 1. I'm just plugging in 1 into the function. Next, I have 1.5, so that'll be 1.5 cubed plus 1. Then I have 2, so that'll be 2 cubed plus 1. And for my last part here, f of 2.5, that will be 2.5 cubed plus 1, and then close the bracket. Okay, so you can do all this on the calculator. If you type it in, you end up getting 16. Okay, so is this an overestimate or an underestimate? Well, if you look at the area here, we're missing this little bit in between. We're actually not getting this area, which we should be getting. So in this case, what we have is an underestimate. Okay, now let's look at right endpoints. So for right endpoints, my graph looks like this. Now all of my rectangles are determined by where the right end of the rectangle meets the function. So that'll give me the height of each of these rectangles. Okay, now we're ready to calculate. So this will be R4. That'll be the right endpoints with 4 rectangles. And the height of the first rectangle is the value of the function at 1.5. times the base, which is again going to be a half, plus, okay, rectangle number 2, that's the value of the function at 2 for the height of the rectangle, and again the base is a half. And rectangle number 3, we have the value of the function at 2.5, and again we have a base of a half. And finally, the last rectangle is the value of the function of 3 for the height, and a base of a half. Okay. And once again, I can factor out a 1/2. So let me do that. So it'll be 1/2 times the value of the function at 1.5 plus the value of the function at 2 plus the value of the function at 2.5 plus the value of the function at 3. Okay, so now I can plug in. So I have my 1/2 out front. Okay, value of the function at 1.5, that's 1.5 cubed plus 1. Okay, plus the value of the function of 2, that's 2 cubed plus 1. the value of the function of 2.5, that's 2.5 cubed plus 1. And the value of the function of 3, that's 3 cubed plus 1. Close the bracket. And if you type all of that into a calculator, you end up getting 29. So again, we can ask, is this an overestimate or an underestimate? And this time we're getting some extra area. These little bits here we don't want. That's more than we need. So in this case, we have an overestimate. So how does our estimate compare with the actual area? Well, we wanted to find the area underneath the function x cubed plus 1 on the interval 1 to 3. And we found that the area was somewhere between 16 and 29. Those were the two estimates that we came up with. The actual area is 22. So that makes sense. It's in between 16 and 29, and it's pretty close to being halfway in between. It's a little closer to 16, but it definitely is in between our two estimates.